everybody in the healthcare field should learn Python, and not because you have to build like an algorithm. They understand how the algorithms work, so they understand the limitation, they understand the capabilities, and then when you come up with a clinical idea saying I can improve patient care in such and such a way, you know how to talk to the programming people saying, hey, this is what exactly I want, and you know what is possible and what is not possible. Whatever you build is going to be the future.
Hello everyone, welcome in the 11th episode of the TheMEDTalk powered by gameofpharma. Today we have with us Dr. Bijun Sai Sir. Sir is the assistant professor at University of Arizona and also passed out from the JIPMER, Pondicherry. Welcome on the show, sir.
Thank you. I'm happy to be here.
Yes, sir. Sir, you passed out from the MBBS from the JIPMER, Pondicherry. Then sir, MS in Biomedical Informatics from the US, sir. So, sir, experience कैसा रहा sir आपका overall?
It was very rewarding, I would say. And how should I put it? There are not a lot of people with my background in that field. Though when I joined it, there were like people from all kinds of backgrounds. There were like nurses, there were like pharmacists, there were a lot of dentists as well. And it was like a really rewarding experience to be able to bring a clinical experience to biomedical informatics, because you have to realize, like, the world is changing. There are so many opportunities here because so many records are now digitized, and we have the opportunity to do so many things that like 10 years ago would have to be done manually by like people spending so much time. So in that way, it's been really, really rewarding, really eye-opening, I would say. Like when I was in India, I honestly did not have like a very clear or idea of what were all the possibilities. But on reaching the US, it was like mind-blowing, actually, to be honest. Yeah.
So, since last few years, you have been working in bioinformatics sector. Will you please tell us about this field? What is it actually? What are the jobs in this? What role we play?
That's an important question, and that's like a question that a lot of students regularly ask. And I would say there is a lot of scope in biomedical informatics, and because it's like a wide field. And essentially, like if you want to understand what biomedical informatics is like applying IT, computer science into healthcare and into improving healthcare. And you know how wide healthcare is. So many pieces are there. Like, there are pharmacists, there are nurses, there are doctors, there is supply chain, and there is people who are like sitting on top of all this. So for biomedical informatics, the same wide variety of choices are there. So there's nursing informatics, who are scientists who work on improving like the nursing workflow. A good example I can give is, let's say there is a ward full of patients, and you want to tell the nurse what to do for each patient. Let's say one patient needs a central line change, another patient needs this some other meds change, and another examined in a certain way. All of this can theoretically be automated, so that every day morning just a nurse can come in and see like a list of tasks, and she can quickly prioritize her time and automate a lot of things. She does not need to keep doing the same thing. If you worked in a hospital, you realize a lot of time we're spending just copying yesterday's charts, writing the same things over and over again. All of that can be automated, and you can also prevent mistakes. So the same way, nursing informatics, there is pharmacy informatics, where you're applying automation techniques and rules to prevent mistakes from happening. One example I heard recently was you don't want whenever there's like an older patient who's getting treated by multiple subspecialties, all of them might be giving them like medication, and you don't want 3 people giving the same patient paracetamol, right? So you can set those algorithms on the back end to keep checking and see if all those prescriptions are reconciled. So if there are like 8 people treating one patient and 8 of them separately sitting in like different departments somewhere else, someone somewhere might miss out on one of the other seven. And it may not happen in all cases, but even if it's like 1 in a million, you can prevent that 1 in a million event from happening by setting and putting those systems in place to prevent that. So that is one application. And there's a lot of work going on in my area, which is like research. So we try to find like patterns, we try to predict what's going to happen as regards to patient outcomes. And we also build the systems which help these nurses and pharmacists do their work more efficiently.
It's like we record the data from our history of patients, like whatever we have given to the patient, and then we analyze the data, and we try to take the healthcare facilities towards excellence every day, every point of time.
Yes.
Is it like
exactly? And here's the thing we have to realize, it's such a wide division, and this is so much scope for improvement. Like every day you could do the best job, and there's still so much more to do. And another thing I tell people is like, you could be a great surgeon, you could be a great doctor, you could be a great pharmacist, but if you are those things, unless you're like a teaching question or a research question, each day you're like treating one patient, tomorrow two, then 3, 4, 5. Like it's like a linear one. So the more the time you spend, more the number of patients. But with biomedical informatics, if you're building systems, if you're doing research, your effort is for the next generation. Once you build that system, until like a better system comes, that's going to work every day. You could be on vacation and your work is still going on. And that is going to stack up every day. And basically, it's a very wide field,
Only like is it totally research based jobs are there in bioinformatics, or like we can also like skilled persons can also join in some places in bio?
So here is one thing and it's not like it's like a problem with India that we think of research as being like a separate field. For me, research is just thinking analytically. So it's basically somebody gives you like two different people give you like two apples, you compare them, right? Who gives a better one? And that essentially is research. So any implementation, any system that you do, any algorithm you develop, you see if it is better than not doing it, or you see it's better than what existing is going on. And to me, essentially, that's research. It's just comparing, it is evaluating, and if you can publish and you can convince others of it, those are that's proper research. But even without that, the core principles of measuring stuff, that should be there in everyone. And if that thinking is there, yes, you don't have to be an academic. You don't need 50 published papers. With just a good mind, fresh mind, the ability to be curious about things, that's all you need. You don't have to be. You don't have to do a PhD. And I also haven't done it. There are a lot of my colleagues also who did not do PhDs. So there are PhD people who are brilliant. I agree. But you don't need to go a lot of depth and publish a lot of papers in order to have an impact. All you need is the idea and the experience. Experience is in the medical experience, with your industry, which is very, very welcome in biomedical informatics. And you should be able to measure and evaluate everything that you do.
Like you said that in India, we think that research is a very different field. That's definitely true. And mostly we see that students have a mindset that those students who have like excellent marks, who are very like proper kind of people, like dream from since their childhood, only they can join research. So it's nothing like that, I guess.
Absolutely nothing like that. I would actually say one of the things I'm most proud of is I graduated in the bottom 4 of my class, 4. I was the last 4 in my class. But the ability to think analytically, and I was always interested in computers. I got my first PC, I took it apart, I put it back together. So if you have the ability, not ability, I would say, interest in questioning things, discovering things, learning new things, because the field is changing dramatically. It's not like, what do you say, it's very different from being like a CA or this thing where you just take an established body of knowledge and apply it again and then again and again. It's changing every day. Latest technologies are coming, and you need to learn and be implementing. So you basically need to learn on your feet rather than be the master of like 5 things or 50 things. That's it. It's totally different. Yeah.
So means we don't need the excellent mind, we just need the curious mind. We just need the people
Exactly.
who
Yeah.
want to know.
Yeah. And because see, like I again said, no, if you build it and you run it, it's gonna run. It's gonna be running in the background, and once in a while, you just need to troubleshoot and all that. But all that will come with experience and time. And you just move on to the next project, and you build the next system, or you build the next project, and you create. So it's like you shift your focus slowly, and it's not like I don't know. I had professors in my college who had like enormous memories, and they expected you to know 18 causes of every single disease or symptom and all that. I feel that you don't need to be like what you call photographic memory. It's the ability to process things quickly, understand things, implement, and always be open-minded. That I would say is like the biggest and most important quality like a biomedical informatics person should have.
Informatics play a major role in the all aspect of the clinical care. And so, I want to know about the aspect of clinical care, मतलब like clinical trials. Like clinical trials के अंदर कैसे use हो सकता है सर bio?
So there are like easy things which are obvious. For example, for clinical trials, you want to automate as much as possible. For example, you're doing a clinical trial of a drug. If there is an adverse event, you'll immediately get notified. And all the data collection aspects, you try to automate. You build like the exact system that's required to collect the most amount of data with the least amount of effort. So that is like the easy part. And there are like some more advanced techniques which, though they were there in like the 80s and 90s, are only becoming more and more applied now, because now we have like the computers, we have the infrastructure that's like available everywhere widely, at least in the US. So we have the ability to apply like much advanced techniques like adaptive randomization. So which is how it's like, so normally when you think of a clinical trial, you have like a placebo group and a control group, and you assign equal numbers and you just do the trials and everything. But now you can actually have like a trial in which you can do like 3 different drugs at the same time, and the algorithm will allocate patients automatically according to how well that group is doing. So if you think like this is like a complicated drug, think of it's very simple. Like, if a drug is doing badly, it's not having good response, the algorithm automatically assigns less patients to that group, and it shifts those patients to groups that are doing better. So, you are not harming the patient. So if there is like 3 drugs that you're testing, and one of those drugs is toxic and one of those drugs is very, very good, by the end of the trial, maximum number of patients would have automatically gotten shifted to the good drug. So you are not waiting for like 6 months, 1 year for a statistician to collect all the data, do the calculation, and then say drug A is better and drug C is bad. All of that is being done automated. And another thing is what I am like part of developing here is what I like to call RTS. It's real-time statistics. It's like the statistical tests are running on the background 24/7. So every day, as the nurse and the clinical staff are entering the data, the statistical tests are running in the background, and it keeps updating every day. So every day, the PI, the principal investigator, and the research team can just take their phone and see how is my cohort doing, and in real time they can see if it is doing better, worse, and for example, like if it's a really really bad drug and it's like within 5 days people are like not improving, you can end the trial early. So there are a lot of things, and these are just examples based on like my experience, based on like what problems like were brought to me. But to be honest, like any aspect of clinical trials and such can be improved, provided like you have the right idea and you have the right understanding.
Can you please explain a bit more about that? What is the future of data in medicine?
So this is like what do you call it? Like it's such a question that the answer will not end. Like essentially, whatever you build is gonna be the future, and the next generation of medical science and knowledge is going to be developed by medical professionals, dental, pharmacy, clinical, who get their hands dirty with data. Because now we have the ability to look at millions of patients instantaneously. Like I have like data sets available which are like 100 million patients. There's one that's 300,000 patients. There's another one that's like 45 million patients. So we have like so much data. Like, it's so many that in the conventional way, nobody would have had the time to see in their entire lifetime. That entire data is like available and you could process it and analyze in like days. I'm saying because it takes that long to like build certain things, but essentially it's available. It's available in the cloud. It's like so easy. So like the future is going to be built by us, by people like you, people like, like students who are interested in taking this new knowledge and taking it to our old textbooks and like, see how we can apply this in the real life and make life easier.
Not we should go for tests. Like ultimately, patient safety is also our responsibility now. So we should obviously go for tests so that we can be more precise about prescribing medicines and all.
Yeah, in India, there's like a cost benefit. This thing, if you prescribe to everyone, that machine will catch fire. But you have to like, do that allocation. But the principle remains the same. Like, you need to provide the best care. And if it is being done by automation, go for automation. But if automation is making more mistakes and also another very important thing is like the cost aspect. It should be cheaper. And that's how like, hospital administration actually invest in that particular effort. This is something that came up, how like, education in the US is so much different. It's because here there's a lot of choice. Like I told you, people who join biomedical informatics can choose like nursing, clinical, pharmacy. They can choose decision support. They can choose public health informatics. There are so many. It's like literally like, after 12th standard, you have those options. The same kind of options are there when you join biomedical informatics is there. But the beautiful thing about it is on the day you join the course, you don't have to decide. You take the first course, you take the next intro course, third intro course, fourth intro course. At some point, you can make that decision at which area you want to specialize, and you take the course according to that specialization. By the end of your master's and a PhD, you are an expert in that particular domain, which you chose according to your comfort level and how well you did it. Because at the end of the day, all of us are different. Like, all of us can't play cricket. All of us can't play football. Some of us are slightly better at cricket than football. Like, so that's like some variation. And every student should get the freedom to choose what they're good at. Patient treatment is just not giving them one injection and one drug and like, magically they're cured. One very good example is with lung cancer. So all the stem cell interventions in the world, all those drugs put together are less effective than smoking cessation. So if you can educate the person to decrease or stop smoking, and in a state you will do much better than giving them all the cutting edge drugs which cost like lakhs and crores. So you can. So that's where we have to realize, like, whatever is best for the patient, that is what we should focus more on. It should not be like single-minded focus on just on drugs or like treatment. It should be holistic, and that's why like we also need to be better, because one thing is, yes, it's the difference here is like between hard and fuzzy. A pill is hard, an injection is something hard you give and you feel like there's an effect. But education, you'll be like, oh, every time I say there's no effect, and that's basically your brain just taking like a few examples and prioritizing it. But on a large scale of things, education matters a lot, and you should also like you should not be discouraged by that, and you should focus, because the opportunity is there, not, and it's like, the potential to impact patient lives is not just by one to one. It can be like a one to many. And if you do like a little bit for so many people, that you may have like a much better impact than somebody who just, seeing one patient at a time.
So, like, sir, here a question arises. The healthcare student should know about the basis of the technology, like basis of the technology, like we can say about the coding or something else about the data. Like, what's your suggestion on this?
Yeah, that's a very good question, because uh, I had some very good people who guided me, and that's absolutely why I'm like here where I am today. Now the world has changed. Like, YouTube has like so much knowledge for, like, how should I put it? Like, lot of the knowledge, technical knowledge that I have right now is publicly available. Like, you do not have to go to like Harvard or anywhere, some great place to get all this basic stuff. The hardest part is application, because that's what you remember best. You can read all the best textbooks in the world, but you'll forget it within 1 month if you don't use it. So that's the hard piece of the puzzle. But there are a lot of resources available currently for medical students. For example, I would suggest that every doctor should learn Python. Every doctor, everybody in the healthcare field should learn Python, and not because you have to build like an algorithm. It's not for that. Because you will always have coders under you. Why people should learn programming, and Python is the easiest, at least in my opinion. Why I say that people should learn Python is that they understand how the algorithms work. So they understand the limitation, they understand the capabilities. And then when you come up with a clinical idea saying, I can improve patient care in such and such a way, you know how to talk to the programming people saying, hey, this is what exactly I want. And you know what is possible and what is not possible. And here in like, let's say in 10, 15 years, somebody's going to graduate, he's going to be surrounded by algorithms. He's going to have like this another algorithm which is like automating follow-up. So you need to know how those things can go wrong as well. So for this, you need like a basic understanding of how computers and algorithms work. So one very easy thing is to just learn Python. There are a lot of YouTube tutorials. And even if you don't have like a computer also, there are now nice apps which you can just like, you could be lying in bed and learn Python, because there's like programs on your phone, apps on your phone which are like drag and drop. So you can learn Python like, upside down, like, while eating like, your breakfast, lunch. You can learn Python on the flight, on your bus. It's so easy these days. And there are cloud computers. So if you are starting to do like this path of data analysis, you're analyzing more and more heavier data, there are cloud computers available which will do all those analysis for you, and there are ones that are freely available as well. There are ones, if you are like starting out, I would say check out Colab by Google. So you will get like an instantly like a small virtual computer from Google, so you can run and learn in Python simple algorithms. And if you want to do like slightly more heavier stuff, you can use resources like Cyverse, which is from the US, and there is Galaxy from Europe. So you can just Google all this and you'll find these. And they will give you like some really dedicated, powerful cloud resources for free. And they do this because they want the next generation of youngsters to develop all these skills, because you are going to develop the solutions for the next 10 years, 15 years. So all of this is available for free. So you don't need to install anything on your computer. You don't need to have like a high-end laptop or anything. You can just get started on that journey and see where it takes you.
We have seen in the next some years, like the social studies, like the history, the Python, and the other data language in our course. Like if we studied in our 9th and 10th, it doesn't matter. I am from the healthcare, I am from the art and science and other background. The Python is compulsory for me. And if I want to make some websites or make a small business for me, I can without any hurdle, I can go for it.
Yeah. And absolutely, I won't say it should be made must, because everybody cannot do everything. But
Yes, sir.
if that option should be there for
Option.
everybody. Yeah, like some people just not interested in that. So forcing them to learn Python would be wrong, I would say.
Yes.
But like, it should be part of the curriculum. They should be exposed to all these things, because see, it's very, very hard to think of things that you have never seen. Like, if you know the story, like, when Srinivasa Ramanujan came to the UK, when he first came, like, I think his name is Hardy, he got him here to the UK. And at that time, he went to the library and he had his notebook filled with all his findings. And he went to the library and he was like, he was reading all these books for the first time in his life. And he actually got depressed because he spent so much time developing things that which already existed. And it's just that he was sitting in Madras and he had no idea that all this development had already happened. And he wasted a large amount of his time simply rediscovering on his own things that already existed or by developed by others. So that way we should not lose time. And like, it's kind of like an arms race. Like, if you get that first atom split, eventually only you will get like an atom bomb, So the same way, you need to start people like understanding the basics of coding, so that like, the next generation of machine learning algorithms, AI, deep learning algorithms will be ready, which will like, next time COVID happens, instantly like all the treatment protocols are ready.
So I would like to add something to it. Actually, I was reading this book called Sapiens by Yuval Noah Harari. And what he have mentioned about humans, that we have how humans got so much of civilization and whatever place we are today. The only reason he thinks, according to him, is cognitive behavior of human. So not like it's learning everything, but we need to work from like the people from different professions. We need to work in a cognitive manner to make something new again.
Right. Absolutely, because see, nobody can know everything. Everybody's knowledge, no matter what, is going to be limited. Absolutely. So you always have to listen to others. They may have experience to things. And like, for example, just take like any two brothers, even if they are twins, there are differences among them. It's just like this twin is slightly better than the other twin, kind of thing. So the same way with medicine and all these medical specialties is that everybody has a unique perspective, unique experience. And if you are able to work together, you can leverage like the best skills in each person. So yeah, it's like working together is 100 times better than working alone. But sometimes you have to learn alone. So that sometimes you should, if you are able to learn alone, you're not waiting for somebody to bless you. You take care of yourself. So. But yeah, ultimately the productivity is always much, much higher if you have part of a good team. Yeah.
What message would you like to give to the young viewers who are planning their future, their career in bioinformatics?
So one thing I would say is always keep learning. This field keeps changing a lot. But of course, and the most important thing is keep your medical knowledge, whatever your core thing that you're learning, because that is what you're going to apply in the future. So it's not like you can throw away your textbooks and just start programming and like, you become like a champ.
Definitely
you need to take your medical knowledge, take all that knowledge and be able to bring it to the patient bedside. So that transformation requires you to develop the basic skills and then just keep learning. I would strongly suggest like doing like a master's or a PhD in the US, mainly because the field is like really booming here and there's a lot of opportunity here. And you can always come back to India. And I'm guessing if you start now, by the time people graduate, I think India will be a much more mature place for job market also mature. All the systems in the US are built by Indians, more or less, directly or indirectly, because we contract, right? We have outsourcing in Bangalore and everything. And all the big companies have headquarters in India, branches in India, but India doesn't have a lot of those systems. So that will change, like how Amazon was there in the US and so many other countries, and somebody started Infibeam and Flipkart in India. It will change. You don't have to worry about it. So this is what I would like to tell them. Like, if you are not the first person to do biomedical informatics in your college or your batch, somebody else will. It's inevitable.
So thank you so much, sir. We learned a lot about the biomedical informatics, which is we can say the new subjects, the new era of medical. So thank you so much, sir. Thank you so much.
Thank you for having me. It's really nice talking to you guys, and wish you the best with all that you're doing. And I'll be watching you guys more than anything.
That's a kind of this. Thank you, sir. Thank you so much. Bye.